Welcome back to our SQL learning journey. Today we begin one of the most crucial sections of our SQL journey, joins and advanced querying techniques. We will be covering all these topics in this video. From understanding the union clause to working with joins, this video will cover up all. Let's start with the union clause. Imagine you have two separate lists of customers, one from your online store and another from your physical store. The union operator allows you to combine these two lists into a single result set. What union does? It takes the results from two select statements and stacks them on top of each other, like combining two separate piles of papers into one stack. The syntax: we write select statement, then union, then another select statement. Both select statements must have the same number of columns with compatible data types. Think of it like trying to stack papers of the same size. Two flavors of union. Union removes duplicates. If the same customer appears in both lists, they'll only appear once in the final result. Union all keeps everything, including duplicates. Every record from both lists will appear in the result. When to use union? Perfect for combining similar data from different sources, like combining customer lists from different regions or merging product catalogs from different suppliers. Let's walk through some examples. Example 1. Combining IDs and names from two tables with distinct results. When we select ID and name from Table A union select ID and name from Table B, we're essentially saying give me all the unique ID name pairs from both tables, but don't show me duplicates. So if both tables have a record for ID 3 with name Cherry, it will only appear once in our final result. Example 2. The same query but with union all keeps duplicates. This time we're saying give me everything from both tables, even if some records are identical. Now that Cherry record appears twice, once from each table. Example 3. A practical business scenario. Combining customer IDs from your customers table with customer IDs from your orders table. This shows you all customer IDs that exist anywhere in your system, either as registered customers or as people who have placed orders, giving you a complete picture of your customer universe. Now, let's talk about intersect. Think of this as finding the common ground between two datasets. What intersect does? It returns only the rows that exist in both result sets. Going back to our customer example, intersect would show you only customers who shop both online and in your physical store. The syntax: similar to union, select statement, then intersect, then another select statement. Important note: not all database systems support intersect directly. MySQL, for instance, doesn't have native intersect support, but we can achieve the same result using inner join or the in operator. When to use intersect? Great for finding overlap between datasets, customers who bought in multiple quarters, products that appear in multiple categories, or employees who work in multiple departments. Let's examine the examples. Example 1. Finding common IDs and names between Table A and Table B. When we use intersect, we're asking show me only the records that exist in exactly the same form in both tables. In our case, only Cherry with ID 3 and Grape with ID 6 appear identically in both tables. Example 2. A business application. Finding customer IDs that exist in both your customers table and orders table. This tells you which registered customers have actually made purchases. It's the intersection of people in our system and people who have bought something. Example 3. Since MySQL doesn't support intersect natively, we simulate it using inner join. We join Table A to Table B where both the ID and name match exactly. This achieves the same result as intersect, showing only records that exist in both tables with identical values. Aliases are like nicknames for your tables and columns. They make your SQL more readable and manageable. Why use aliases? When you're working with multiple tables or long table names, aliases save typing and make your queries cleaner. Instead of writing customer_information repeatedly, you can use C as an alias. 2 types of aliases. Column aliases. Rename columns in your output for better readability. Table aliases. Create short references to tables, especially useful in joins. The syntax. Use the as keyword followed by your chosen alias name. For tables, you typically use single letters like C for customers, O for orders. Best practice, always use meaningful aliases. While C for customers is fine, avoid cryptic abbreviations that make your code hard to understand later. Let's look at practical examples. Example 1. Column aliasing for readability. Instead of showing columns named first name and last name, we can display them as customer first name and customer last name using as. This makes our output much clearer, especially when we're joining multiple tables that might have similar column names. Example 2. Table aliasing in joins. When we write from customers as C in a join orders as O, we're creating shortcuts. Now instead of typing customers.firstname and orders.orderdate, we can simply write C.firstname and O.orderdate. This saves typing and makes complex queries much more readable. Example 3. Essential for self-joins. When we alias the employees table as both E4 employee and M4 manager, we can join the table to itself. We're saying select E.name as employee name, M.name as manager name, taking the same table but treating it as 2 different entities to show the employee-manager relationship. Cartesian join or cross-join. This is the mathematical concept of combining every row from one table with every row from another table. If you have 4 customers and 10 products, a cross-join gives you 40 combinations. When is this useful? Rarely in practice, but it's helpful for generating test data or creating all possible combinations, like matching every employee with every possible shift, or every product with every possible discount. The syntax: use cross-join between your table names, or simply list tables separated by commas in the from clause. Self-join. This is where a table talks to itself. Imagine looking in a mirror and having a conversation with your reflection. Common use case: hierarchical data like employee-manager relationships. The same table contains both employees and their managers, so we join the table to itself to connect employees with their supervisors. The syntax: we use the same table twice with different aliases, typically something like E for employee and M for manager, then join on the relationship column like manager ID. Let's explore the examples. Cartesian join example. Combining every customer with every product using cross-join. If we have 4 customers and 4 products, we get 16 combinations: Alice with laptop, Alice with mouse, Alice with keyboard, Alice with monitor, then Bob with all 4 products, and so on. This creates every possible customer-product pairing, which might be useful for generating a product recommendation matrix. Self-join examples. Example 1. Finding employees and their managers. We join the employees table to itself where the employee's manager ID matches another employee's employee ID. This shows us that Bob reports to Alice, Charlie reports to Alice, and David reports to Bob. It's like looking up the organizational hierarchy. Example 2. A more complex scenario: finding employees who earn more than their managers. We join the employees table to itself on the manager relationship, but then add a where condition to only show cases where the employee's salary exceeds their manager's salary. This might reveal interesting compensation patterns or potential issues in your organization structure. Inner, left, right, and full joins. These are the core joins you'll use daily. Think of them as different ways of combining 2 tables based on matching criteria. Inner join. This is the strictest join. It only shows records where there's a match in both tables. Like a guest list where only people who are both invited and confirmed attending get shown. The syntax: select columns from Table 1 inner join Table 2 on matching condition. Now time for the example. Getting customers who have placed orders. When we inner join customers and orders on customer ID, we only see customers who have actually placed orders. David Black doesn't appear because he has no orders, and order 104 doesn't appear because customer 5 doesn't exist in our customers table. Only confirmed relationships are shown. Left join. This keeps all records from the left table and matches from the right table. If there's no match on the right, those columns show as null. Think of it as keeping your entire customer list and showing order information where it exists. Example 1. Getting all customers and their orders. With left join, we keep every customer from the customers table. Alice, Bob, and Charlie show with their orders, but David Black appears with null values for order ID and order date because he hasn't placed any orders yet. We preserve all customers regardless of whether they've ordered. Example 2. Finding customers who haven't placed orders. We use left join but then add where order ID is null. This filters our result to show only customers where the right side, orders, had no match, effectively finding customers who haven't made any purchases. Right join. The opposite of left join, keeps all records from the right table. Less commonly used since you can achieve the same result by switching table order in a left join. Example 1. Getting all orders with customer information. Right join keeps every order from the orders table. Most orders show with customer names, but order 104 appears with null customer information because customer ID 5 doesn't exist in our customers table. It's an orphaned order. Example 2. Finding orders from non-existent customers. We use right join and then where customer ID is null to find orders that have invalid customer references, useful for data quality checking. Full outer join. This is the most inclusive. It shows everything from both tables, whether matched or not. Like combining your customer list with your order list and showing all customers, even those who haven't ordered, and all orders, even those from non-existent customers. Key insight: the choice of join type determines which records you see in your final result. Choose based on what story you want your data to tell. Getting everything from both sides. Full outer join shows all customers, including David who hasn't ordered, and all orders, including the orphaned order 104. It's the complete picture showing matched relationships, unmatched customers, and unmatched orders all in one result set. Division is a theoretical concept that SQL doesn't implement directly, but it's incredibly useful for find all queries. The concept: find entities that are related to all entities in a specific set. For example, find suppliers who supply all required parts or find students who passed all required courses. How we simulate it. We use group by with having and count to ensure we have relationships with every item in our target set. It's like taking attendance. We only count someone as complete if they are present for every required session. The logic: group by the entity we're looking for, count distinct relationships, and compare that count to the total number of items in our requirements set. When to use: quality control scenarios, compliance checking, or finding complete sets of relationships. Let's work through the examples. Example 1. Finding suppliers who supply all parts. We have 3 suppliers and 3 parts, P1, P2, P3. We use group by supplier name and having count, distinct part ID, equals the total number of parts. Only supplier C supplies all 3 parts, P1, P2, and P3. Supplier A only supplies P1 and P2, while supplier B only supplies P1 and P3. The division operation identifies only the complete relationships. Example 2. Finding customers who have ordered all products. This is more complex because we need to trace through multiple tables, from customers to order details to products. We group by customer and count distinct product IDs, comparing that count to the total number of products available. Only customers who have ordered every single product type would appear in this result, those who have tried your entire catalog. The using clause is a shortcut for joins when the columns you're joining on have identical names in both tables. What it does: instead of writing on table1.column equals table2.column, you can simply write using column when the column names are the same. The syntax: replace the on clause with using followed by the common column name in parentheses. Benefits: cleaner code, and the result automatically eliminates the duplicate column that would normally appear when joining on the same column name. Limitation: only works when column names are identical. If column names differ, you must use the traditional on clause. Let's see the examples in action. Example 1. Joining customers and orders using customer ID. Instead of writing on c.customer ID equals o.customer ID, we simply write using customer ID. The result is identical. We get customer information combined with their order information, but the syntax is cleaner and the output automatically eliminates the duplicate customer ID column. Example 2. Joining orders and order details using order ID. Again, instead of on o.order ID equals od.order ID, we use using order ID. This connects each order with its line items, showing order date alongside product details and quantities. The using clause makes the relationship clear and concise. The over clause introduces us to window functions, one of SQL's most powerful features. Traditional problem: with regular group by, you either see individual rows or aggregate summaries, but not both together. Window function solution: the over clause lets you calculate aggregates while keeping individual row details visible. The concept: think of it as looking through a window at your data. You can see individual records while also seeing calculated values across related groups of records. Key components: partition by defines the groups for calculation. Order by defines the sequence for running calculations. Window frame defines exactly which rows to include in each calculation. Common uses: running totals, ranking, percentage of total, moving averages. Let's examine the practical examples. Example 1. Calculating each employee's salary as a percentage of their department total. Using partition by department, we calculate the sum of all salaries within each department, then divide each individual salary by that sum. For instance, if marketing has 2 employees earning $75,000 each, the department total is $150,000, and each employee represents 50% of their department's salary cost. Example 2. Calculating running totals of order amounts by customer. Using partition by customer ID and order by order date, we create a cumulative sum of each customer's orders over time. Alice's first order of 150.00 shows as 150.00, but her second order of 75.00 shows a running total of 225.00. This tracks each customer's spending progression chronologically, useful for analyzing customer lifetime value growth. The minus or except operator is like subtraction for datasets. What it does: shows records that exist in the first query but not in the second query. Think of it as give me A but take away anything that's also in B. The syntax: first select statement, then except or minus an oracle, then second select statement. Practical example: find customers who exist in your database but have never placed an order, or find products that were discontinued but still have inventory. Database variations. Oracle uses minus, while SQL Server, PostgreSQL, and newer MySQL versions use except. Let's explore the examples. Example 1. Finding IDs and names in Table A but not in Table B. Using except, we get apple and banana. These exist in Table A but don't have matching records in Table B. Cherry and grape are excluded because they exist in both tables. Example 2. Finding customers who exist but have never placed orders. We take all customer IDs from the customers table and subtract those that appear in the orders table. This reveals customer 4, David, is registered in our system but has never made a purchase. This is valuable for identifying inactive customers who might need marketing attention. Example 3. Finding discontinued products that were previously ordered. We take product IDs from order details, products that have been ordered historically, and subtract current product IDs from the products table. This would reveal products that customers have ordered in the past but are no longer in your active catalog, useful for inventory management and understanding what products you've discontinued. Real-world databases often require joining multiple tables to get complete information. The approach: chain your joins together, connecting each table through common columns. Think of it as following a trail of breadcrumbs through your database. Planning your joins. Identify which tables contain the information you need. Map out the relationships between tables. Start with your main table and add joins one by one. Test each join addition to ensure you're getting expected results. Best practices. Use table aliases to keep your query readable. Consider the order of joins for performance. Use appropriate join types based on whether you need all records or only matching ones. Always verify your results make business sense. Performance tip: join on indexed columns when possible, and consider the size of tables when determining join order. Let's walk through a comprehensive example. Example 1. Getting complete order information with customer names, order details, and product information. We start with customers, join to orders, connecting customers with their orders, then join to order details, getting the line items for each order, and finally join to products, getting product names and prices for each item. The result tells a complete story. Alice Brown placed order 101 on January 10th, which included one laptop at $1,200 and two mice at $25 each. Bob Green placed order 102 on January 12th for one keyboard at $75. This four-table join gives us the complete business narrative of who bought what, when, and for how much. Example 2. A more complex scenario involving employee hierarchy and order processing. If we had a process by employee ID in our orders table, we could join customers to orders to employees again, for managers. This would show us which customer placed an order, which employee processed it, and who that employee's manager is, creating a complete audit trail from customer through staff hierarchy. Remember, joins are about relationships and storytelling with data. Practice these concepts with real data, and always ask yourself, what story am I trying to tell with this data? The answer will guide you to the right join strategy. And that's a wrap for this video. Thanks for watching this video, and if you watched this far then please give it a like, share it with your friends, and do subscribe to the channel. See you in the next one. Till then, happy learning.